Okay, so now that we've finished up that review of chapter 3 and we start to move on, here's what here's why we needed to go back and talk about that a little bit. In chapters 1 and 2, we basically discussed um, statistics. Okay, so we looked at those basic needs to be able to work with a set of data. Chapter 3, we talked about probability. What we want to do here in chapter 4 is start to combine those ideas. We want to look at data sets statistically and look at probabilities that are involved and how they relate and what we can do with those. Okay, so what we're going to be looking at in this chapter are different kinds of discrete probability distributions. Okay, it's a set of distributions that are represented by their probabilities, and we're going to look at some special forms and look at how to use the calculator and tables to be able to find them. And I'll try to keep some of this stuff short so that we can get through problems kind of quickly. Okay, first of all, in the set on definitions down below, you see definition for a random variable. Okay, random variable is just the event that we're trying to look at. Now, each one of those events, when we did statistics, the frequency, okay, each one of those was represented in those tables where we did the tallies. Okay, if you're in the frequencies. So in those individual items on that far left column, we listed all those individual X values, and then we used frequencies to talk about how many times they occurred. Now, what we're going to do is instead of using frequencies, we're going to use probabilities, okay, to represent those. Okay, so that the random variable are the actual numeric values, the events, okay, that are going to take place. The second definition of probability distribution, okay, is a description that gives the probability for each value of the random variable. Okay, what's the chance that that thing's going to occur? Okay, a discrete random variable has either a finite set of values or a countable set of values, where countable refers to the fact that there might be infinitely many values, but they can be associated with a counting process, like 1, 2, 3, etc. Okay, we talked about discrete. Okay, we're going to start off with some exercises discussing discrete again. The other side of discrete is continuous. Continuous means the values can be associated with measurements on a continuous scale without gaps or interruptions. So we talked about lengths, dimensions involving measurements, like weight, capacity, length, all of those, because they can be broken down in a smaller scale units, okay, then we considered those continuous. Okay, so we'll look at some of those when we get to the exercises. Now, with each one of those probability sets that we're going to be looking at, they're going to ask you to do two things. Number one, determine yes or no, is it a probability distribution? And then if it is, they want you to perform some calculations. Find the mean, the variance, and the standard deviation. Okay, now if it's not, then we don't have to worry about those calculations, but here's the things you need to know, okay, for the requirements of what determines a probability distribution. Okay, so number one, if you add up all of the probabilities, they have to equal 1. Okay, all of the probabilities added together have to equal 1. Okay, number two, all of the individual probabilities have to be between 0 and 1. Okay, so you can't have negative values. Okay, and obviously you can't have, if it has to equal 1, you can't have values that are greater than 1. Okay, so we'll see that. They'll give us some examples here where we're going to have to perform that. And then below, I'll show you this, how to use these specifically, but these are the formulas for how to calculate the mean, variance, and standard deviation for different probability distribution. Okay, so remember Okay, mu, that symbol right there, it looks like a U with a tail in front. Okay, that is the symbol for finding the mean. Um, the one that we'll probably use, we usually use the shortcut, and I think that's the second one here, um, for finding variance, and then that final one for standard deviation. All we're going to do is square root it. So when we get to those exercises, that part of it there, then I'll go into a little bit more detail. Okay. Um, once we have those values, okay, the round off rule for mean, variance, and standard deviation, just like we said before, okay, with these three measurements, you always take the measurement one more decimal place than the values of each random variable. Okay, so if the random variables are integers, then you're going to go one decimal place. If all of the integers are one decimal place, then you're going to go two. Okay, so always one more than what the original values contain. And then the range rule of thumb, once we know what the mean is and the standard deviation is, then we can find maximum and minimum values for what we call usual. Okay, remember we had a set of values like on a number line. In one of the sections, we talked about if it was below 2, okay, or above or below -2 or above 2, we considered those unusual. Anything in between was usual or common. Okay, that's in using those z-scores. Okay, what we're going to do is we're going to go back to calculating those a little bit too. Okay, now, and then they really, this next part of it here, okay, using probabilities to determine when results are unusual. The kind of the number, looking at this part right down here, we tend to use 0.05. Although it's not absolutely rigid, it's kind of a good indicator. Anything less than or equal to 0.05 for a probability means it's probably going to be unusual or unlikely to occur. So you'll see that in some exercises too, where they're going to use that value. And then we have a problem. I don't know if we're going to see this later. They talk about finding expected value. Expected value, if you look at that, that really is just another name for finding the mean. Okay, so we'll look at that some more as well. On the bottom of the page, you have 9 problems down there, and all they want you to do, okay, is determine is that value, is that random variable a discrete or a continuous number? Okay, now if you have number 2, the weight of gold stored in Fort Knox. Well, measurements like weight, height, time, um, length, distances, all of those are continuous. So weight falls into one of those measurement categories. So weight would be continuous. Okay. Number 8, the number of movies currently playing in U.S. theaters. Okay. Values like that can be counted or are countable. Okay. You're not going to have a partial movie. You're either going to have a movie playing in its entirety or it's not playing at all. So numbers like that become countable numbers. Okay, number 8 is an example of a discrete value. Okay, so there's the first part. Just again, going back to those kind of values. Number 10 on the back side is one more. Okay, on questions 11 through 14. Okay, 11 through 14, they give you a set of values, or they describe a situation. The situation there isn't real important here, but they give you a probability distribution over to the right. Okay, and so first thing we're going to do is we're going to answer yes or no. Is it a true probability distribution? Okay, and if it is, then they want us to find the mean and the standard deviation. Okay. Oh, crap. Okay, let me find my notes. You doing okay? Okay, so on number 12, the first thing I'm going to do is I'm going to add up all the probabilities that are there. Okay, so the 0.22, 16, 21, 16, okay, that becomes okay 0.75. Okay, clearly the sum of the probabilities is not